Check, check, 1, 2. Mic's coming through. Get some music. Check Twitch as usual. All right. Welcome, welcome, all 0 of you. All right. So, Google Gemma has been announced. Google's first open source network in a while, first open source project in a while. So we'll read through kind of the developer blog. They don't go into too much details, but I mean, because it's open source, you can really just play around with it and do whatever. So we'll read through. It's supposedly based off of Gemini, which I'm sure is true. I mean, we went through the Gemini paper and they just say, oh, we feed all the modalities into a transformer. Ooh. So yeah, it's just a transformer large language model. But that's open source. So that's new for Google. Well, not new, but definitely not common nowadays. Actually, I kind of like the audio like this. All right, and then so we'll read through it, and then afterwards, I think it's time to finish up Audio Sleuth. I just need to develop the Mel spectrogram transformation, and then make sure the test works, and then just push the code, call it a day, and then maybe start brainstorming some new projects. So we'll see. Let's see. So let's go to Google Gemma. So introducing Gemma, introducing new state-of-the-art open models. So Gemma is Google's new open source project. According to them, Gemma is built for responsible AI development from the same research and technology used to create Gemini models. So this is a transformer-based large language model, obviously scaled down, as we will see. And my guess is that it's scaled down because I really doubt that Gemini Ultra Pro Mega Max, or whatever they call it, is only 7 billion parameters. Let's be real. It's probably a mixture of experts of that goes up to 1 trillion plus. According to GPT-4 leaks, we know that it is a mixture of experts, an 8-way mixture of experts, I believe, of 200 billion parameters, adding up to about 1.6 trillion parameters. And OpenAI, despite being absolutely massive and having practically half of Microsoft's cloud available to them, they still do not come. They do not compare to Google. So I'm willing to bet that Gemini is infinitely larger. Obviously not infinitely, but substantially larger, especially Gemini at the highest level. So yes, it is the same research and technology used to create Gemini models. When they say that, they just mean, yeah, we scaled up the transformer mechanism, but it doesn't mean that it's going to have, is going to be nearly as powerful or as large as Gemini. So at Google, we believe in making AI helpful for everyone. We have a long history of contributing innovations to the open community, such as with transformers, yes, TensorFlow, BERT, T5, JAX, AlphaFold, and AlphaCode. Today, we are excited to introduce a new generation of open models from Google to assist developers and researchers in building AI responsibly. So, introducing Gemma open models. Gemma is a family of lightweight, state-of-the-art open models built from the same research and technology used to create the Gemini models, aka transformers. Developed by Google DeepMind and other teams across Google, Gemma is inspired by Gemini, and the name reflects in the Latin gemma, meaning precious stone. Accompanying our model weights, we're also releasing tools to support developer innovation, foster collaboration, and guide responsible use of Gemma models. Gemma is available worldwide starting today. Here are the key details to know. So there are going to be two sizes, 2 billion and 7 billion. Each size is released with pre-trained and instruction-tuned variants. So in total, there are going to be 4 models, the 2 billion and 7 billion, the base model, and then the instruction-tuned variants, which is kind of their, think of it as like the ChatGPT variant of it. So it is fine-tuned specifically for a dialogue, kind of back and forth dialogue. A new responsible generative AI toolkit provides guidance and essential tools for creating safer AI applications. What is this? This is so this is safeguards that's put in place in the toolkit. Now this toolkit looks like it is a part of their cloud. So I don't know how useful this will be if you are a bad actor. I think you could just take the model and do whatever you want. But yes, so when building Gemma, you should take a holistic approach to responsibility and consider all the possible challenges at the application and model levels. Which is good. I mean, this is nice that they did it, but this isn't going to really shift the needle, substantially at least. We're providing tool chains for inference and supervised fine-tuning across all major frameworks, JAX, PyTorch, and TensorFlow, but it's through Keras 3.0. So I remember reading about this earlier. Keras 3.0 actually, this just links to the GitHub repo itself, but yeah, so Keras 3 specifically does have native Torch support. So yeah, you can install the backend of your choice. So that is pretty cool. So you have essentially all the tool chains and the supervised fine tuning available to you in either JAX, PyTorch, or TensorFlow. They're ready to use Colab and Kaggle notebooks, as well as Hugging Face, Max Text, NVIDIA Nemo, TensorRT LLM, which I believe this is their chat. Oh no, this is just the optimization toolkit. Never mind. I know that NVIDIA released the LLM chat on Windows, but this isn't the case. So yeah, you can just go to Hugging Face right now. You can go NVIDIA Nemo if you're working at a startup that already has this. Same with TensorRT. It's already there's already integration with these tools. So if you're using any one of these, you can just kind of plug and play. Pre-trained and instruction-tuned Gemma models that can run on your laptop, workstation, or Google Cloud with easy deployment on Vertex AI or Kubernetes. Optimization across multiple AI hardware platforms, including GPUs and TPUs. Now, this I found very funny because they did collaborate. Google did collaborate with NVIDIA for this model. So AMD, go fuck yourself, pretty much. Terms of use permit responsible commercial usage and distribution for all organizations, regardless of size. Now, why would they say regardless of size? That is because Llama from Meta, they're in their license, it actually is the case that if you are a company that has above something like 700 million active monthly users, some crazy number, you are not allowed to use Llama. So this is kind of they have this because of kind of the funny it was very funny when Llama was released and Jan LeCun and his team was kind of patting themselves on the back for saying we're open source, but not everyone can use it. So I think this is kind of a jab at them. State-of-the-art performance at size. So yes, this is the case that the 2 billion and 7 billion achieve best-in-class performance for their size when compared to other open models. Now, this is the case if you go to the Hugging Face leaderboards, for example, which, let's see, Hugging Face LLM leaderboard. Number 1 right now, it should be Google Gemma. If we go by average, it's not. So the question is, why was... I thought that... dude, I could have sworn that on LinkedIn, Clem, the CEO of Hugging Face, was just talking about how this is like number 1, but maybe it's a different leaderboard. Okay, that's fine. They're capable of running directly on a developer laptop or desktop computer. Notably, Gemma suppresses significantly larger models on key benchmarks while adhering to our rigorous standards for safe and responsible outputs. Responsible by design. So this is obviously talking about how, you know, they really heavily regulated this model. Additionally, we use extensive fine-tuning and reinforcement learning from human feedback to align our instruction-tuned models with responsible behaviors. To understand and reduce the risk of the risk profile for Gemma models, we conducted robust evaluations, including manual red teaming, automated adversarial testing, and assessments of model capabilities for dangerous activities. These evaluations are outlined in our model card, which points to Kaggle. And then we mentioned the toolkit already. So within the toolkit, you have safety classification, debugging, and guidance. Optimized across frameworks, tools, and hardware. So we talked about the multi-framework tools. Because this is done in Keras, you can choose your back end of choice. Cross-device compatibility. This is because when optimized, you can comfortably run a 2 billion parameter network if you have like a 3080. And I'm willing to bet even like 3060, 3070s can actually run these reasonably well. Not top of the line, but still reasonably well. So we've partnered with NVIDIA to optimize for NVIDIA GPUs specifically. So if you have an AMD GPU, sucks to suck. Get good. Skill diff. Get better. Get better neural optimizers. Get owned. From the data center to the cloud to local RTX AI PCs, you should be good to go. And then obviously it's going to be optimized for Google Cloud for GPU, TPU, and CPU performance. And then you can get free credits if you have something meaningful to work on. I don't, because I'm dumb. So I encourage you to go to this website and then you can apply to the Google Cloud credits if you have something that you believe is worthwhile. There we go. So that is Google Gemma. That is pretty cool, in my opinion. And I'm glad that Google is actually making a change towards... it's not a change towards open AI, towards open source AI, but it is something, and it is the first thing they've done in actually quite some time at this point. So with that in mind, let's jump to finishing up Audio Sleuth. So I do want to finish this up, and I have been feeling like doing a new project, but I don't want to just end the project haphazardly. I do want to kind of complete the scope and call it. So let's here. Okay. So the trainer should be good. I need to add the Mel spectrogram to augmentation and then debug the deep speech too. And then we'll see how I'm feeling about documentation, because let's be honest, no one's going to use this. So where was I here? Let's go to augmentations. Have the label resample the augmentation. Okay, cool. So let's add class Mel spectrogram. All right, so first, let's move this over here. Let's close these for a sec. And then Will Smith AI spaghetti. Yes, that is exactly what I needed. So if you remember, the whole point of this is to kind of have a light wrapper such that the labels are aligned with whatever transformation you have. So what we will do here are typical parameters. So I'll have the sample rate. So then I'll take these here. That will be rather useful. Size. I'm gonna kind of repeat all this. This is a bit arbitrary. And then what else do we need? Number of mels. I'll add that as well. For mels, power normalize. Center. That's default true, that's fine. Okay, cool. Then we can just run with this. Spectrogram with self dot fs self dot and fft self dot win size self dot n hop size, and then number of mels will be self dot n mels. And I will also set this by default. Actually I'll have the user specify it. Spec equals self.mel spec of audio, and then framed label self.label. of labels. No spec, frame labels. Frame labels. Wait, but we have okay, cool. That was very easy. Patience. Add no spec. All right, cool. So let's check out docs about augmentation status. And then what's new in the README? Oh, it's just these. Okay. Okay. Yeah, I'll just call it here. I don't. Dude, I'm like so over this project. I've been working on this since December, and I don't know. I just kind of lost. I lost the momentum, and I lost the vibes for it. So I'll just end the project here. Really, just call it. Yeah, I don't. Starting new projects is always so tough because there's just so much I want to do, but I don't know where to start. So I guess we will. I mean, let's explore. First, let's check GitHub. Do I have everything? Why is the text so big? Alright, there we go. Yeah, no, everything seems good 2 minutes ago. And then README 1 minute ago. Okay. So yeah, this is Audio Sleuth. Audio Sleuth. Get sleuthed. Alright. So now the question is what to work on next. How do I define a project scope? Well, first and foremost, what do I want to do? What is a reasonable scope for this? And, you know, I don't know, man. You know, you have these days where you are just on top of everything and you feel great, and then the next day you just have no idea what you're doing. So I guess I'll just have some ideas here. And then I guess we can search. So for example, no. I've been really interested in MLX, for example. This is essentially PyTorch or NumPy, but completely optimized for Apple Silicon. It is a very new repository. A lot of it's done in C++ and Metal, which is Metal is essentially CUDA, but for Apple's chips, which would be interesting. So one thing that I quite liked about MLX from Apple is that, well, the chips specifically have unified memory, which means that you don't need to, as they say, you don't need to transfer data. So what is this? You can use the supported device types without transferring data. So what does this mean? This means in a typical setting. So what this means is that in a typical setting, in PyTorch, for example, wow, in PyTorch, if you have, let's say, your model here, and your model is hosted on your GPU, and you have your data, let's say this is a tensor, batch size 32, height, width, 3 channels. Let's say this is image data, and this is hosted on your CPU. What you have to do in order to feed the data into your model as a forward pass and get an output, you either need to convert your data and send it to the GPU, or you need to send your model to the CPU, which, I mean, obviously you wouldn't do this because it's going to be a lot slower for the forward pass, but you have to make sure that your model and your data are hosted on the same like memory, the same device, as PyTorch will say. So if you call model.device in Python, this will return, let's say, CUDA 0 as a string, and this is how you know where your model is hosted. But because Apple's chips are in a unified memory model, you can literally have model on your GPU, which I don't know how they call it because it's not CUDA, and your data can be on CPU. I doubt this is the syntax, but bear with me. And you can do model data. You can send it as a forward pass and then get an output, and there will be no problem. So that's really nice. That's really cool, and very nice. So I've been quite interested in doing something like that, or at least working on MLX. Issue is I don't have anything that's Apple Silicon, so that immediately makes an issue for me that I would have to like buy a Mac Mini or something like that to get this working, or to at least get something working. But I'll have to consider that. So this is, so I'll keep ideas here. And then what we will do is I will box off MLX and then pros and cons. So pros for me is that this would be, I would contribute to a repo that's maintained. Cons, I need money for Apple chips. Sad. All right. Now, obviously, this is going to be a huge pro for me. And this is actually what I'm hoping. This is kind of going to be the bare minimum for whatever I work on next, because for so long I've been just kind of building out my own projects, and that's great and all, and it's a lot of fun, but it gets to a point where I want to contribute to something that's a bit larger and really test myself outside of the work I usually do, which is contributing to a larger code base that I'm a lot more familiar with. And there's plenty of challenge in contributing to a code base you know really well. But I do want to take that next step and challenge myself in something I don't know at all. So MLX is promising. I will need to, again, potentially buy like a Mac Mini or something, and then go from there. Meta, so Facebook AI research. So Facebook research has so many cool projects. But the question is, what can I contribute to? What is there a lot of one-off models that the only pull request they may accept is like bug fixes, minor things, not necessarily building out features. Now this was really cool. This paper that just came out recently, which I found very very cool. I do want to go through the paper on video. I haven't had time to read the paper though, to kind of give a meaningful explanation of this, but what they propose here is kind of like an unsupervised feature learning for video, which I do think is a more meaningful step towards machine-based understanding as opposed to machine-based generation. So I would need to go through this if I wanted to do the paper review. But in terms of, issues, this is still a very new repository. So I don't know I wouldn't know how to navigate something like this. Usually I would want something with a few more issues that's raised. That way I can really just kind of dive headfirst. But we will see. So maybe JEPA. Pros, I would say being a new repo is both a pro and a con. Can contribute more. But a con would be that it is I would have to locate the issues. Now, this isn't necessarily the worst con on the planet, so I might prioritize this a bit more. It's just that it will be a bit more difficult to actually locate issues, because then I would really have to go through the code. And again, this is just the network itself. I don't think there's any this isn't like a toolbox or anything that is intended to be scaled per se, or have new features. So just model repo. I don't know. What else is there? Hold on. I have been, so maybe not MLX specifically, but I would like to work on something that is, I guess, a bit lower level. So I guess this is a pro. Uh, Lower level, more hands-on with layers. I think it's really interesting and really fun to build out like the lowest level of like a convolutional layer, attention layer, whatever it may be. I think it's a lot of fun to build stuff out, especially on the driver side. So like Apple Metal, CUDA, whatever it may be. So I think this is something that that may be worth a consideration. Let's switch the. Yeah, Xformers is really cool. I had a discussion again to try to see what we can do for what we can do for MPS, so Metal Performance Shaders, Apple Silicon. It seems like they may want to have a third-party repo before integrating it into Xformers. I don't think it's at 1.0 just yet. Yeah, so it's still early development. Let me make a note of this. Xformers. So this is lower level. There is custom CUDA kernels. I don't know what the cons would be. Let's see. Well, it is limited because this is just, as the name implies, this is just custom transformers. So if there's like a new, we're not going to be working on like the Mamba architecture, the state space models, because this is just exclusively transformers. So it is limited in that capacity. Let's see. A lot of conversation around AMD RFCM, that's pretty cool. Multimodal. Let's see those. Torch Multimodal is a PyTorch library for training state-of-the-art multimodal multitask models at scale, including both content understanding and generative models. This could be kind of interesting. What are the issues? Five days ago. Okay, so there is meaningful updates here. Let's read through the documentation, maybe. Torch multimodal. Modules, transforms. What are the modules? Layers, encoders, fusions, losses, masking, optimize. The issue. with lava. Large language. Oh, and vision assistant. I see. Okay, this could be interesting. I don't know what the is there a pull request for lava already? Refactor F lava. Is this latent diffusion? It's a pretty new model. Very new. Paper. Let's see what the paper. So let's see what this paper is doing. Is that you have a vision encoder, so you have the XV, which is the image that's fed into your vision encoder, and then it's linearly projected with W, and then you have the query, which is also projected. And then what do they use? Oh, they use clip for the image, and then what about XQ? Is that also fed into clip? And you get the. This could be. This actually could be really interesting to try. Where is? Let me. Have you worked on this to any capacity? I'm interested in picking this up if not. I mean, we could check his profile to see if he has anything. October. No, it seems like he's been busy with other things. What was his last? Yeah, so it seems like he's been busy with something else. Maybe I could pick this up. Add support for lava. And this could be interesting, actually, multimodal. And I would actually learn a lot. I've actually never played around with a multimodal network before, so I think multimodal might be the move. So support for lava. That'll be interesting. Then the bulk of the work for the model should be to add the LLM. A couple pointers is this and this. And then we also have a PR for rotary positional embeddings, which, has it been merged yet? No, it has not. What about root mean square layer norm? And then the transform. Oh, so this is the decoder layer. And then we have the code here as well as a reference, which will be really good. All right, cool. So let's see what this guy has to say about lava. And then was Coco. Oh, this is closed already. Okay. All right, so my multimodal might be the move. That would actually be pretty cool. We have May. What's audio? Mask auto encoders. That list. Because we could also introduce something like clap as well from Microsoft. So this could also be another idea as well. Yeah, I think there's there are some worthwhile there could be some worthwhile ideas here. Let's see what he has to say about lava. If I don't get anything by like tomorrow, I might propose I might just do it and then introduce Flap, for example, unless they are only doing meta AI based projects. So we'll see. Very interesting. Masked autoencoders are scalable vision learners. Meta AI definitely loves masked based approaches. This self supervised style. And I mean, I don't blame them. It is such an interesting paradigm of training. Yeah. So they mask stuff out and then they kind of train it to reconstruct. As you can see, this is looks like the reconstruction, and this is the ground truth. Yeah, it is very interesting. This kind of looks like a dog though. That's funny. But no, good, very good, very cool. All right, cool. So yeah, let's see what they say. I could start with lava, maybe introduce um, other multimodal style um, networks. So we'll see. Coco clip. Clip was meta. Wait, was clip meta? That's interesting. I didn't know clip was. Oh no, it's Salesforce. Okay, so it seems like they're not. So my assumption was incorrect. Wait, flip and flip. Did they? Huh? I don't know what just happened, but okay, they have other networks as well. It's not just. All right, so this was fair. Was this also meta? Yeah, also Meta. So a lot of the stuff is just their networks. Yeah. Um. Yeah, it could be interesting. Could be interesting. All right, so let's see what will happen. Um. Yeah, I'll probably end the stream here. I don't have much else to do today, so I'll probably just end it here. Thank you for tuning in. Um. Yeah, I'll see you all on Friday. Today is Wednesday, so yeah, I'll see you all on Friday. By then I'll know what to work on, and then I think I'll just begin working on the multimodal, kind of contributing to Torch multimodal, which I think will be a nice, very nice and fun challenge. So I will see you all on Friday. Peace.